A function is given fx is equal to 3x minus x cube. We need to draw the curve. So first we will try to find the x and y intercepts. So in order to do that, let's say when x is equal to 0, what is the value of y? So the function is basically y is equal to 3x minus x cube. So when x is equal to 0, we can see y becomes 0. So that means it cuts the y-axis at 0. Similarly, when y is equal to 0, this is 0 here, 3x minus x cube. So we will try to solve it for x, and we can see that x here, 3 minus x square is equal to 0. So either x is equal to 0 or plus minus root 3. That means it cuts the, so if we look at the graph here, this is x-axis, this is y-axis, and this is a point here, which is this is the origin, and it cuts it, the point goes through, the curve goes through origin because x is equal to 0, and it goes through y is equal to 0 both. So that's origin, and then we can see that it cuts the x-axis at other 2 points, which are plus minus root 3. So plus, let's say this is plus root 3 and this is minus root 3. Should be equal, so maybe I will call this one as plus root 3 here and not that one. So basically this one goes back. So anyway, so this is plus root 3 and this is minus root 3 and 0, of course. So these are two, so these are the 3 points that the curve goes through. We know now. Now we will try to find if there are any stationary points, that is, we will see if there are maximas and minimas, which there will be probably. So let's do when f prime x is equal to 0. So we will find the first derivative of the function and equate it to 0 to find the stationary point. So 3x minus x cube is the function. I'm rewriting it. So f prime x becomes 3 minus 3x square. So if we equate it to 0, 3 minus 3x square equals to 0. So x square is equal to 1. So x is equal to plus minus 1. These are 2 points which probably are maxima and minima, which are stationary points. Now we will try to find the nature of the stationary point. So we will see, we will do the second derivative. We will find the second derivative and see the sign of second derivative at those points. So second derivative becomes, this is the first derivative, second derivative becomes minus 6x. This is minus 3, this one goes 0, 3, this one goes 0, and minus 3x square becomes minus 6x. This is the second derivative. So when x is equal to minus 1, f double prime x, what is the sign here? Minus 6 times minus 1, which is plus 6. So this is positive. That means this point is a minima. We have discussed this in a previous video. So this point is a minima, x is equal to minus 1. And when x is equal to plus 1, f double prime x is minus 6 times 1, which is minus 6. So this is a negative. So this is a maxima. So now we know the signs of the nature of the stationary points. There will be somewhere here which is plus 1, that will be a maxima, and this has to be a minima. It has to go this way, but we will try to find the, I haven't found the y values of those points, but I will do that now. So when x is equal to minus 1, y is equal to, the function is, I keep forgetting the function, 3x minus x cube, 3x minus x cube, so that's minus 3, and then minus 1 cube, which is minus 1, minus 1, so basically it becomes plus 1. So minus 3 plus 1 is equal to minus 2. So the point is minus 1 and 2, that's that one, and when x is equal to 1, y is equal to 3 minus 1, which is 2. So the other point is 1 and 2. So yeah, because that's a maxima and this is a minima. This is a maxima, so the point is 1 and 2, and this is a minima, the point is minus 1 and 2. So the curve, now we can draw the curve because we know enough, we have enough information to be able to draw it. This is a minima, this point is a minima here, and then it goes that way. This point is a maxima, goes that way, it crosses the axis here and here, we know that, so it will go this way and this way. So this is our curve. We can just show this.